Welcome to the another class of design of RCC structure. In this class, I am going to design a square footing with the given data. So let's not waste the time and start the problem. So first we have to read out the problem very carefully. Design a square footing of uniform thickness for an axially loaded column of 450 mm by 450 mm size. The safe bearing capacity of soil is 190 kN per meter square. Load on column is 850 kN. Use M20 concrete and Fe 415 steel. So, as per question, WC is given, that is 850 kN. Bearing capacity Q0 is also given, that is 190 kN per meter square. For M20 grade of concrete, FCK is 20 Newton per millimeter square, and Fe 415 steel, Fy is 415 Newton per millimeter square. Now, the first step for the design is load calculation. WC is 850 kilonewton, which is given. Now, self weight of footing, that is WF, may be considered as 10% of WC, that is 85 kilonewton. In the last video, I have already discussed about the aspect and procedure of design. On that video, I have discussed that WF may be taken as 10% of WC, that is load of column. So WC plus WF is equals to 850 plus 85, that is equals to 935 kilonewton. So from this we can easily find out the area of footing, capital A, that is equals to WC by WF by QU or Q0, that is equals to 935, and by bearing capacity, that is 190, that is equals to 4.92 meter square. So side of the square fitting is obviously root over of the area, that is 4.92, that is equals to 2.22 meter, say 2.25 meter, we can assume is as 2.25 meter. So the factored soil pressure due to column load only Pu is equals to 1.5 into 850 by the area 2.25 into 2.25, that is equals to 251.85 kilonewton per meter square. At the right side of the screen, as per given data, the size of column is drawn, and as per our calculation the footing is also drawn. So each side of column is 0.45 meter and each side of footing is 2.25 meter. So next step is depth of footing calculation. So to calculate that, we have to use three criterion: one-way shear criterion, two-way shear criterion, and bending moment criterion. Among these three, which value is more, we have to take that value in our consideration. So first criterion, it is depth of footing by one-way shear criterion. That means shear should be act in either this side or that side. Okay, but in case of square footing, all sides are same, so we have to calculate it for only one time. Okay, so critical section shall be at a distance d from the face of the column. So you can see here, from the face of the column at d distance, the critical section is shown. Shear force due to fractured soil pressure at critical section is equals to 2.25 within bracket 2.25 minus 0.45 by 2 minus d, that is the area up to this is the area, into pu, that is 251.85, that is equals to 566.66 within bracket 0.9 minus d. So now we can assume 0.2% reinforcement steel has been used. So for 0.2% of steel and M20 concrete, tau C will be 0.32 Newton per millimeter square as per table number 19 of IS 456 2000. Okay, you can check the table from IS 456 table number 19. Okay, so now shear force resisted by the section is equals to tau C into x into d. So x means one side of footing, and as this is square footing, we can take any side because this is same value. But in case of rectangular column, we should design it for two times, for x axis shorter span and for y longer span. So in this case we don't have to consider that because we are here we are designing square footing. Okay, so tau c into x into d, that is equals to 0.32 into 10 to the power 6 by 10 cube into 2.25 into d, so that is equals to 720 d. Okay. Actually the value of tau c is 0.32 Newton per millimeter square. By this 0.32 into 10 to the power 6 by 10 cube, I have converted it from Newton per millimeter square to kilonewton per meter square for our calculation. It will help in our calculation. Okay, so that is equals to 720 d. So this is equation 2. Now we have to equate equation 1 and equation 2. Then we get 566.66 within bracket 0.9 minus d, that is equals to 720 d. So from this equation we can get the value of d, that is equals to 509.99 by 1286.66, that is equals to 0.396 meter, that means 396 mm. So as per one way shear criterion, small d, that means depth, is 0.396 meter. Now next step, depth of footing by 2A shear criterion. Okay, this is also called punching shear. Now considering critical section is at distance d by 2 from the face of column. So we generally we take this in previous video. I have already discussed how we can use this and design steps and aspects. So critical section is at d by 2 distance from each face. Okay. So perimeter of the critical section will be 4 into 0.45 plus d. 0.45 is the value of one side of column, that is equals to 1.8 plus 4d. Now shear force at critical section is equals to pu 251.85 into 2.25 into 2.25 minus 0.45 plus d whole square, bracket close, that is equals to 1274.99 minus 251.85 within bracket 0.2025 plus d square plus 0.9 d. This is equation 3. Now shear force resisted by the critical section the maximum allowable shear stress is equals to 0.25 root over FCK, that is equals to 0.25 root over 20, that is equals to 1.118 Newton per millimeter square, or we can write 1118 kilonewton per meter square, 1118 kilonewton per meter square. Now shear force resisted tau c, that is 0.25 root over FCK, the value is 1118 into 1.80 plus 4d into d, that is equals to 2012.4 d plus 4472 d square. Equating 3 and 4, we can get the value of d. So now we have to equate 3 and 4. So 1274.99 minus 251.85 within bracket 0.2025 plus d square plus 0.9 d is equals to 2012.4 d plus 4472 d square, or we can write d square minus 0.423 d minus 29 is 0. So from this we have to find out the value of small d. So d is equal to 0 minus 0.423 plus minus root over minus 0.423 whole square divided by 4 multiplied by 0.29 by 2. So we know this Acharya's formula. From this we can calculate d, that is equals to 0.367 meter or 367 mm. Okay. So by two-way shear criterion or punching shear criterion, we get the value of d is equals to 0.367 meter. Okay. Now we have to go to next step. Next step is depth of footing by bending moment criterion. So critical section is at the face of column, bending moment at the critical section, mu is equals to 251.85 into 2.25, 2 within bracket 2.25 minus 0.45 by 2 into 2.25 minus 0.45 by 4, that is equals to 566.66 into 1.80 square by 8 is equals to 229.498 kilonewton meter, that is equals to 229.498 into 10 to the power 6 Newton meter. Okay. So these all formulas I have discussed in last video. You can check with this video and tally this the formula and these values. Now moment of resistance at critical section is now xu max by d is 0.48 for Fe 450 steel, and Ru is equals to 2.76 for M20 concrete and Fe 415 steel. So in last video I have shown you the value of Ru which we have calculated and made a table. Let's check again. So for Fe 415 steel and M20 concrete, we have to check out the value of Ru. Okay, so let's see the table again. So this is the table. So for M20 concrete and Fe 415 steel, K or Ru is 2.76 Bd square. Okay, so Ru is 2.76 as per the table, where Ru or K is 0.36 xu max by d within bracket 1 minus 0.42 xu max by d bracket closed into FCK. So from this table we can find out the value very easily. This table calculated by oneself. Okay, so this table is not given in as code. So you have to, as per the question, you have to remember few values that will help you, and that is a shortcut to solve the problem. Otherwise you can use directly the equation from NXG. So you can use that procedure also. So as you see, the value of RU is 2.76 for M20 grade of concrete and Fe415 steel. So mu limit is equals to RU into B into D square, that is equals to 2.76 into 2250 into D square, that is equals to 6210 D square. So this is equation 6. Now we have to equate equation 5 and equation 6. So by equating equation 5 and equation 6, we get 229.498 into 10 to the power 5 is equals to 6210 d square. So d is equals to 192.24 mm or 0.192 meter. So from equations A, B and C, the highest value of D obtained is for one-way shear criterion, that is 0.396 meter or 396 mm. So let's adapt D is equals to 400 mm. So overall depth will be 400 plus 8 as we take 16 mm diameter bar, and plus 50, where 50 is taken as clear cover. For footing we have to take minimum clear cover of 50 mm. So overall depth is 458 mm, let's say 460 mm. Now we have to calculate area of steel reinforcement. So this equation is from Annex G of IS 456-2000. Mu is equals to 0.87 Fy into AST into T within bracket 1 minus AST Fy by BD FCK. Therefore 229.498 into 10 to the power 6, that is the value of mu, is equals to 0.87 into 415, that is Fy, into AST, which we have to find out, into 400, that is D, within bracket 1 minus AST into 415 by 2250, that is B, into 400, that is D, into 20, that is FCK, or AST square minus 43,369.37 AST plus 68918,318.32 equals to 0. So again we have to apply Acharya's formula. So AST is equals to 43,369.37 plus minus root over of 43,369.37 square minus 4 into 68918,318.32 by 2, that is equals to 1652.03 mm square. Now this much area of steel is required, so minimum reinforcement required is 0.12% of area. So 0.12 into 2250 into 460 by 100, that is equals to 1242 mm square, that is less than 1652.03 mm square. Using 16 bars, so a diam, that means dia of one bar, area of one bar is equals to pi by 4 into 16 square, that is equals to 201 mm square. So spacing should be 201 into 2250 by 1652.03, that is equals to 273 mm. So provide 16 dia bars at the rate 270 mm center to center in each direction. Okay. So this is the design data. Now we have to draw. So this is the elevation and this is the plan. Okay, so elevation, in elevation you can see the column is 450 mm and here is the footing which is 2250 mm and the depth is 460 mm, clear cover is 50 mm and 16 mm dia bars at the 270 mm center to center in both direction is provided and the plan is looks like this. This is the plan. So that's all for this lecture. But we before at the end we have to check for development length. So development length we have to follow clause number 26.2.1.1 of IS 456/2000. Okay, so LD is equals to 0.87 Fy into phi by 4 tau BD, that is equals to 0.87 into 415 into dia bar 16 by 4 into tau BD is 1.92 for M20 concrete and Fe415 steel as per IS 456/2000, that is equals to 752.2 mm and available length of bars is 2250 minus 0.45 by 2 into 1000, that is 900 mm. So this is greater, hence okay. That's all for this lecture. Thank you for listening.